Yep.
All right, good afternoon, everybody. Thanks for taking the time to join us. My name is Sean Maday. I'm a product manager on the Maps for Business team.
And I'm Avnish. I'm a technical solutions engineer in the enterprise team.
Our goal today is to talk to you a little bit about a project that's near and dear to our heart, and that is the ability to take the consumer experience of Google Earth and Google Maps and take it completely offline, behind the firewall, or into kind of bandwidth disenfranchised areas. We're going to throw a bunch of nomenclature at you today, and we're going to try to paint a picture for you, but it would be helpful for us if we could just kind of do a quick poll of the audience, and I'm going to ask a few questions. How many of you have ever heard or used Google Earth Enterprise? Heard of or used Google Earth Enterprise? Great, okay. For those joining us via video, there's thousands of people in attendance, and they all raised their hand. How about Portable? How many of you have ever used Portable? Product we call Portable. Okay, great. And then how about Google Maps Engine? How many of you have ever been hands-on with Google Maps Engine? Great. Okay, that's very helpful. Thank you. And as we go forward, for those of you who weren't familiar with any of those three products, we'll make sure that we make that clear to you. But so before we begin, I want to touch on some current events. We woke up this morning to headlines that a series of really severe tornadoes had struck just southwest of the Dallas-Fort Worth area. And a lot of times we see this type of headline, but these headlines get kind of lost in the news cycle. But instrumental to the relief and response effort in the aftermath of a critical incident or a natural disaster like this is usually a map, and the context that that map can provide to us as kind of fellow Americans or fellow citizens of Earth, but also to first responders and emergency managers who are going to be trying to restore and provide relief for those affected. So I just wanted to provide some context with the map. I'll show you here. These are the 4 counties that were primarily affected. The green dots, or the green place marks you see here, were kind of initial observations that were recorded this morning by several local news affiliates. And then the blue place marks you see here are actually confirmed touchdowns that the National Weather Service just put out a few hours ago. And as we zoom in and we pan around these affected areas, the map is a really interesting way for us to kind of get some appreciation for what this human terrain and this natural landscape looks like. And for those emergency managers who are going to be responsible for understanding the scope and extent of this devastation, and for those first responders who are going to be going door to door, assessing damage and looking for those who are injured or afflicted, these sorts of maps can be absolutely critical to understanding and getting a lay of the land. And so what we want to do today is we want to illustrate to you that these maps are obviously very impactful and very useful in an online setting, but they can become even more useful, and they can become a force multiplier in an offline scenario. And so actually the demo I'm showing you here is completely offline. This is all running on my local machine from the localhost URL you see at the top of the screen. All of these map tiles were cut from Google Maps Engine. These are Google's map tiles down to level 17. I get some very granular street level understanding, but all of this is coming offline. So in the aftermath of these critical incidents, when there's limited or no connectivity to the outside world, that's really where this story of offline begins. So as we take you through today, that's going to kind of set the expectation for what you should see and what we're going to show you on how you can extend on these platforms. You've heard some big numbers over the last few days from folks like Brian McClendon and Mono Marks, and they've talked to you about the absolute ubiquity of the Google Maps and Google Earth platforms. 1 billion users a week, 1 million websites out there on the open internet have implemented the Maps API. Google Maps has become the platform whereby people go to make fast, informed decisions about geography, right? So asset tracking, looking for information about where to live, where to shop, what to buy. Google Earth becomes the substrate or the backdrop by which these sorts of engagements occur. So the focus of our team and the focus of the products we're going to show you today is really on how to extend this functionality into situations and scenarios where that connectivity to the outside world is unavailable or is significantly degraded. So we talked through the emergency management or emergency response type scenario, but there are many other scenarios that play a role here. Paramount among them, things like research and outreach, things that take researchers and scientists to far off areas of the globe where they just don't have connectivity to the rest of the world. And then there's certainly lots of interesting defense and public safety applications for this sort of technology. So with that, let's dive in and talk a little bit more about Portable. Google Maps Engine Portable, or Portable as we call it, is the product that takes the familiarity of Google Earth and Google Maps offline behind the firewall, deploys it on your own network, on your local device. We have builds of Portable for Mac, Windows, and laptop. And to be totally transparent, I want to be very clear, this is an enterprise track. These are generally paid products. Although we have a very robust outreach and develop for good effort. And if you work with an NGO or you work in the nonprofit space, we would love to get you a grant for this sort of functionality so that you can empower your constituents with this technology. We're also excited to kind of foreshadow some events foreshadow some releases in the months ahead, where we will take this capability to Android tablets and smartphones. Portable, as it exists today, is a laptop application, desktop application, with builds for Mac, Linux, and Windows. It scales from 1 to 10 users, so you could either run this scenario locally on your individual machine or sit in a small tactical operations or team-type environment where you could share that experience across up to 10 devices. And at its essence, behind Portable is really just a lightweight Tornado web server. For those of you who aren't familiar with Tornado, it's an open-sourced, kind of massively scalable web serving application, very powerful, and it provides the foundation by which we deliver the portable functionality. So as we step deeper into this portable ecosystem, Portable is the client software that will serve up a Maps or an Earth experience. But what it serves is a portable cache, or as we may refer to it, a cut, a map or a globe that has been packaged and prepared for offline use. There's a couple ways right now to build one of these cuts. The first is with Google Earth Enterprise. For those of you who've used Google Earth Enterprise or have access to Google Earth Enterprise, you have the ability to extract a portion or even the entirety of your Google Earth Enterprise Maps and Earth experience into this file format so that you can use it in these offline settings. We're also really excited to bring online in the next couple months the capability to cut this rich map data out of the Google Maps Engine enclave. And so all of you, I'm sure have heard, but we would love to get Google Maps Engine into your hands. And if you come visit us at the Sandbox, come visit us at the booth, we'll give you the information so that you can start a free trial of the Google Maps Engine platform. Very exciting way to take lots of imagery, terrain, and vector data, process it in the cloud, and then very soon you'll be able to pull out these maps and Earth experiences for completely offline use. The output of either of these two processes is a .glc file. Right? This is your portable cut. With that cut, you could do some interesting things, but let's first dive into what that cut is. That cut, as we call it, is really just a single binary file. It can be very large, it can be very small. It's really restricted only by the file size limitations of your file system. Carries the .glc extension. And in the past, if you've used Google Earth Enterprise, you may have seen a .glm or .glb file. .glc is the new kind of standard wrapper that will encompass all of these portable caches going forward. We also have the ability to include into this binary file a custom point of interest search, so that if your users or your constituents, your stakeholders need to search against this rich corpus of data you're giving them offline, we want to give you the ability to define the points that they can search against. So now that we have this cut that we've taken from Google Earth Enterprise or Google Maps Engine, we can drop it seamlessly into the portable server. And once it's on the portable server, we have some really interesting ways to interact and extend this functionality. And Avnish is going to dig into this a little deeper. But at a high level, you can think of this as the Earth API and the Maps API you're familiar with from the consumer internet, packaged and deployed in a slightly modified state on your local device. You can also interact with these caches via the Google Earth Enterprise client, that is to say our version of Google Earth Pro that isn't hardwired to Google servers, and we'll show you some examples of that when we jump into the demos. And then, of course, we have some interesting and evolving ways for you to interact with this portable map or Earth experience using Android devices. So with that, let's talk through how we create one of these portable maps or globes. The basic building block of cutting a portable is really to define your area of interest. And that's done with a KML polygon. That can be as simple or as complex a polygon as you see fit. It can be a single polygon or it can be a multi-polygon, depending on your use cases. It is specified simply with KML. Once you've specified your KML, you'll make some decisions about how deep into the cut. And when I say deep, I'm talking about how many zoom levels deep into the cut you will want to extract that data. and then how far outside of the cut you're going to want to extract that data. For those of you who aren't familiar with zoom levels, it's the way that we take a lot of map data and make it discoverable at different zoom levels with varying degrees of resolution and numbers of tiles based on how far in or out you have zoomed and panned. So today, for those of you using Google Earth Enterprise or who have access to a Google Earth Enterprise system, you have a couple different ways to kick off one of these cuts. The first is with a simple HTML5 interface. That is something I'll show you right now. So this is the cutting interface that will be released with Google Earth Enterprise 4.5 in just another couple weeks. Here I'm looking at a two-dimensional map. This map has fairly low resolution satellite imagery for the entire world, 4-kilometer satellite imagery, so fairly low resolution. But as I zoom and pan, you'll notice the map is truly a Google map. This looks and feels and interacts like a Google map. From the cutter here, I have the ability to define an area of interest. So let's say I want to take kind of the western seaboard of the United States, just shy of the Washington border. Oop. And once I've defined my polygon here, I can also kind of redefine the points of interest. From there, I'll have the ability to state a name. So maybe I want to call this my West Coast globe. I can throw in a description. As you can imagine, over time, you can generate a lot of these cuts on your local machine. You can generate a lot of these cuts that go out into the field. So you're going to want to be as descriptive as possible to make sure that you capture what is inside of this cut. So certainly here, we'll just make an example. But you can be as verbose as you would like. And then using these pull-down menus, we'll decide, again, how deep we want to cut inside the polygon and how deep we want to cut outside the polygon. So here I'm simply going to make some arbitrary selections. We'll say zoom level 4 for the entire world. That's a very low resolution, the entire world represented on a very few number of tiles. And we'll cut to level 18 inside the polygon. That is a large number of tiles down to generally about 1 meter resolution if we were talking in imagery. And then we can kick off that cut. It's an asynchronous process. It kind of happens here in the browser window. Lots of dialogue coming back to tell us how big that cut is getting. And this was a fairly small cut because I had low resolution imagery, so it's indicated that the cut is complete. In addition to that user interface, HTML5 user interface that we package with Google Earth Enterprise, we also have command line utilities that would allow you to script this workflow. And we'll dig a little deeper into that in a couple slides, but some really exciting ways there to kick off cuts programmatically. And the neat thing here, and this is kind of a departure from the capability we've been able to offer with the online version of Google Earth or Google Earth Enterprise, we have the ability with Portable to let you offer your users and your viewers up to 5 layers of imagery. So I'd like to show you that now. Here I'm logged into the Google Earth Enterprise client. I'm going to zip back to Portable, and I'm going to change the Portable map that I'm currently serving. So this is the Portable interface as it exists in, as I mentioned to you, HTML5 interface. It looks about the same on Mac, Windows, or Linux. Here I'm going to say that I want to serve up my Las Vegas 3D globe. Now that that's serving, I can jump back to the Earth Enterprise client. And in addition to being logged into Google's globe, which isn't necessary but just happens to be what I have here, I'm going to log into my local host address. And you'll notice in the lower left-hand corner, I've now added a second database that I can explore. And as we zoom in, I can actually turn off all the imagery trained vector data associated with Google's globe. So we just see this small patch of alpha-masked imagery that we've cut over the Las Vegas Strip. And now you'll notice in the lower left-hand corner, we have 5 different imagery layers that represent this particular scene. So as a user now, I can come back and forth and look at these individual dates. I can see what this scene looked like in 2010. I can see what it looked like in 2003. We've had this ability to support historic imagery in Google Earth for a long time. But Portable gives you the flexibility to actually use the transparency slider to step back and forth between these individual scenes. So we can really look at how this landscape has changed between any of the 5 imagery layers that are denoted in the lower left-hand corner of our Google Earth display. Very cool way to kind of understand that change over time. And we're really excited, and we have a really strong team of engineers working hard on the ability to allow cutting of portables from Google Maps Engine. So this is coming soon, a little bit later in 2013. But in the Google Maps Engine interface, we'll have a browser-based capability for you to define the polygon, your point of interest, choose the layers you want to cut, and kick off an asynchronous cut, take large amounts of map data, combine them into a single binary file that you can pull from the cloud and serve locally on your machines. This is working today. Actually, some of the demos I'm showing you here, like the Texas demo, was actually cut from Google Maps Engine. So again, we're just kind of working on making this capability more robust, and we're really excited to get it in the hands of trusted testers in the next couple months. In addition to what we're offering inside of the HTML5 interface, we also are going to allow programmatic access. So again, you could kick off these cuts programmatically. Our vision going forward is really to offer some composite solutions that allow you to leverage both the cloud, your on-premise geospatial investments, and new emerging form factors for devices to create familiar Google Earth and Google Maps experiences that your users can interact with completely offline. Whether those tiles come from Google Earth Enterprise, Google Maps Engine, maybe even cutting Google Base Map tiles as we mature that capability, you should be able to consolidate these individual cuts and create the custom map environment that your users need, but with the familiarity that Google Earth and Google Maps has instilled in these consumers. So right in line with this is this ability to cut programmatically. And what I really like about this is we harken back to that disaster response scenario. This gives us some really exciting ways to proactively respond to natural disasters and critical incidents. And what do I mean by that? Well, the National Weather Service puts out the map you see in the upper left-hand corner. 24 hours a day, 365 days a year, they're monitoring all 3,141 different counties in the United States, and they're monitoring the weather patterns that are affecting the people inside of those counties. They're putting out this large common alerting protocol, XML, or CAP as they kind of call it. At every given moment, this thing is updated, and it shows which counties are under a flood advisory, which counties are under a severe winter weather advisory, which counties are under a tornado warning. And with this sort of rich data, and the programmatic access to cutting that's currently available today in Google Earth Enterprise and quickly becoming available in Google Maps Engine, we can start to script some really interesting solutions. So for instance, the Texas demo I showed you earlier simply scraped through this XML, looked for counties that had progressed from a tornado watch to a tornado warning. It then combined the geographic bounds for those counties into a single polygon, passed that polygon into the Google Maps Engine cutter, and allowed us to kick off that cut programmatically the minute those warnings were issued. So to follow that chain of kind of thinking, that would allow your organization, or first responders anywhere, to have access to this rich offline map data by the time that they get the alert that a storm is impending. Again, to do this, we'll just throw up a couple code samples that would let you kind of dig into this, but it's as simple as just using some Python to reach out, grab that XML from the National Weather Service, read it into your local system, parse through it, and then as you parse through it, look for alerts that pass your particular threshold. Those warnings, those alerts, tornadoes, floods, whatever may fit your absolute use case. Another interesting implementation of this is something that our colleague Sean Woltman has put a lot of passion behind for the last few years, and that is making this data available offline in response to large hurricanes. And so the National Weather Service, in conjunction with the National Oceanographic and Atmospheric Administration, puts out these cones of uncertainty whenever a major hurricane is bound for the United States. We can, again, follow the same workflow to reach out, grab that data, do something with that polygon to convert it to KML so that we can use it inside the Google Maps Engine or Google Earth Enterprise cutting infrastructure. Again, here this was as simple as just a wget to grab it. We needed to unzip the zip file that the National Oceanographic and Atmospheric Administration and the National Weather Service had put out, and then just use an open source vector processing tool like OGR to convert it from a shapefile into a KML. Once we have that KML, we can feed it into Google Maps Engine, we can feed it into Google Earth Enterprise, and we can do that programmatically to cut this data and make it available. So now that we've set the foundation for what Portable is and what it can do for you, Avnish is going to talk about how motivated and creative developers like yourself can extend this functionality to do interesting things in your applications completely offline.
Thanks, Sean. So Sean has nicely described the workflow for cutting and creating and serving your portable globes. And so now let's say you've done all that, and now you have this GLC file that's sitting on your hard disk. It could be tens of megabytes or several terabytes in size, depending on the cut that you made. And now you're interested in serving this out and building your applications on top of it. Now, sure, you could launch the enterprise client or the mobile client that come out of the box with these products and view your globe that way, but where's the fun in that, right? you want to be able to build your own custom applications that are targeted for your specific use case and environment. So how do you do that? Well, the key is the Google APIs that you all know and love, namely the Google Maps API and the Google Earth JavaScript API. Now, conveniently, we offer these with the product. They come bundled with Google Earth Enterprise Server as well as the portable server. They're typically kept in, they align in terms of the version with the latest frozen release that's out on google.com. And fundamentally, the version of the API that comes with the portable server is the same as what you find on google.com with respect to, the events such as the mouse over click, double click. You have the same type of controls, zoom, pan, scale, plus all the custom controls. You have overlays such as symbols, markers, polylines, etc. But there are some subtle differences in the API that we provide with the portable server compared to the one that you load on google.com. Some of those differences include the way you actually call and invoke those APIs, because obviously you're not going to be getting them from Google. You're going to be getting them from the portable server, so they need to be loaded in your web page from there. And there's certain classes that are offered to make it easier to interact with the 2D and the 3D map tiles. And I'm going to talk about that in a moment. And as you might also guess, there's no support for certain types of services like the direction service, Panoramio, Street View, etc. Services that require access to Google's infrastructure. So before we get into the sort of nitty-gritty, let me review the workflow for hosting a 2D map on Portable. Typically, you're going to build your 2D map either in Google Earth Enterprise Fusion or, as Sean demonstrated, in Google Maps Engine. You're going to choose the layers of interest, your imagery, your vector layers, possibly some terrain. At that point, you're going to publish that 2D map. In the case of GME, that's just a matter of one click and making it available to the folks that you share. And in the case of Fusion, you would typically publish it to an Earth Enterprise server. At that point, you're going to cut a piece of that map corresponding to the region of interest, exactly the way Sean demonstrated. And the output of that is going to be that GLC file. At that point, you're going to start serving that GLC file through the portable server, and then you can start building your custom HTML applications that load the JavaScript API. So what I'd like to do now, I have here a little USB memory stick that contains a GLC file from a globe that I published from Google Earth Enterprise. It's a relatively small one, a few hundred megabytes from a sample natural view globe that I had created. It's just got, it has the base imagery layer and maybe one or two vector layers. So according to the blue box, I had built that globe of mine in Fusion, and then I published it to my Earth Enterprise server, the red box, and then I cut it using the Portable Cutter UI. So what I'm going to do now is insert this USB disk on my laptop. And before doing that, I'm going to go completely off the grid. Turn off Wi-Fi here.
That was like one of those corny moments in a movie where they use the title of the movie in the actual dialogue. You said off the grid. I like it.
So I fire up my natural view US portable globe, which automatically, by double-clicking it, kicks off the portable server that I have running here on my Windows laptop. I click on View 3D, view the map in a browser. It shows me a preview, essentially, of the globe I'd created. Now, if you look at the URL here, at this point, this map, this globe, is being served from my Windows machine on port 9335. So at this point, I can start interacting with this globe directly. So I have a little Hello World example that I'm going to go over, that I'm going to load here. And let's take a look at the source code for this. Let's see. These 3 lines here is where I actually load the Google Maps API that's on my portable server. After the Bootstrap loader, the fusion_maps_v3 and the other JavaScript helper file essentially load the entire Google Maps API into this application. So that's one of the differences. And then down here, you'll note the use of a class called gFusionMap, which is, you could think of it as an extension of the google.maps.map class. And it's what you need to instantiate in order to create your 2D map in your HTML container, which is typically a div element. This class accepts the same options as google.maps.map and can be used in the same way. And that's it. That's all you need to do to load the 2D map in this simple Hello World application. So let's have a look at maybe a few more examples. I have one that loads some symbols and polylines. Now, here what I'm displaying is certain markers that can be used to decorate not just points, but polylines as well. It's making use of the visualization features of the Google Maps API. But you'll note, this map is completely interactive. In other words, I interact with this map in the same way that I would any Google map. This was the area that I had cut in San Francisco. The area outside of it is, well, outside of my cut region, but I can zoom in to the highest resolution that was in my original base map. And I can zoom, pan, scale, all that good stuff. Again, this is running completely offline. Let's have a look at another example, perhaps a heat map. This is showing a time-based animation of the expansion of Walmart stores since the 1960s till now. You can, again, use the visualization capabilities in the Google Maps API, varying the intensity and the color spectrum of the heat map. And as before, I can interact with this just as with any other Google map. I believe I have one other example here to show.
These are the same visualization demonstrations and code examples you'll find online using the public Google Maps API. The power here, of course, is that it's all running off Avnish's local machine via that localhost URL.
Right. Again, this is another time-based animation showing the expansion of these Walmart stores.
Our goal with these demonstrations and code samples is really to highlight to you the flexibility of this platform.
And this is against my base map that I had cut, and it's all being served out of this USB drive that I have here. Okay, let's go back. I guess I got to get back online to resume the presentation.
We can use mine. Here you go. I got mine, Avnish.
Okay, thanks.
Yep.
So in that Hello World example that I just showed you, that I've highlighted the lines here that would be needed to load the JavaScript API off the portable server instead of from google.com. And again, you want to pay close attention to the use of this gfusion map, which is what you would need to instantiate.
All these slides will be made available after the talk, so again, these code samples aren't meant to be eye charts. We want to leave these with you as a resource that you can reference later.
Right. And very analogous to the 2D maps, we offer the 3D map API, which is the Google Earth API. It also is supported through the use of the Google Earth plugin, which runs on Windows and Mac. And that API includes all the capabilities that you're probably familiar with, from place marks to balloons and historic imagery, et cetera. And in addition, it offers the capability to connect to multiple globes. So this is a snippet of a Hello World example for 3D. Again, you're going to load the JavaScript API from the portable server locally. That's what the script type line is. And in the google.earth.create instance call, there's a fourth parameter, which is the URL of the database that you're connecting to, an alternative database other than Google's default one. And in this case, I'm pointing back to my local machine because my portable server is running on port 9335. Other than that, you use the Earth API exactly the same way. So extensibility doesn't just end with the maps and the Earth API. It can be leveraged through Python as well, and Sean's going to speak about that now.
So as I mentioned to you, the basis of Laptop Portable is really the open source Tornado web server. Well, inherent in that and packaged in that is the most current release of Python. And so we're providing you APIs and tools that allow you to leverage that Python inside of your offline applications to interact with the Google Earth or Google Maps offline environments. So you can imagine this as a framework for adding extension services on top of the Google Earth and Google Maps portable experiences that you get as a baseline with Portable. So you can execute Python scripts, you can install standard Python libraries, and you can engage in some interesting interaction between the Maps environment and the type of backend system that would normally be reserved for a web server, right? So as you can see in the chart here, you could grab view-based parameters from either Google Earth or Google Maps, grab those click-based events from the Google Maps environment, pass those to this Python engine, do something interesting with them, and return those responses as either JSON or KML, depending on if you're using Google Earth or Google Maps. So one example of that, and just two code snippets, again, don't expect you to read these, but want to make sure that we provide them in the slides so you can reference them after the talk. First is just creating a network link and specifying which parameters from that network link should be passed back from the Google Earth environment back to the Python server. And then a couple lines of Python here to grab that grab those parameters from the URL, do something with them, and then return that experience as KML. So let me show you an example of that here. I'm back in Google Earth. I'll turn back on some of Google's offline imagery. Now as I zoom and pan here, you'll notice I have this network link on the left side. This is pointing back to a local service running on my localhost address here, so localhost 9335 and extension service. And all this service is really doing is taking the center point for the screen, or just about the center point for a screen based on terrain, and returning it to me as a KML. So this interaction is the type of interaction you'd expect to see with a KML network link and a back-end web server on the internet or on your local network. Here, all of this KML is being generated on the fly by that Python engine running with Portable. So a very simple hello world type demonstration. Our goal today was really just to show you this platform and this product, to let you know that our team is working very intently on taking the capabilities of Google Earth and Google Maps from the online cloud-based environments down to those tactical scenarios where internet connectivity is degraded or unavailable. We're really looking to your creativity and your technical expertise to take this platform, build it out in interesting ways, integrate it with your offline applications for your constituents and stakeholders, and take this ecosystem forward. So with that, we're just about to wrap up here. I would like to just say that I'm very fortunate that I get to be the product manager for this awesome suite of products. I get to come out and present to you, but I'd be remiss if I passed on this opportunity to really thank the awesome team of engineers we have back in Mountain View and abroad who are doing really impressive things at Google scale to take the world's geospatial data, make it consumable online and offline for your use. And with that, we have about 4.5 minutes. We would love to entertain any questions you might have. And sir in the back of the room, you want to come use the mic so we can capture it for the video? Thank you. Sorry to make you walk across the room.
So
now can you go use that microphone? No, I'm just kidding.
So a big use case here is data capture. How are we doing with capturing data, then uploading it back to Google Maps engine?
Yeah, great question. So we view this as the offline product that gives you the view-only capability. And then what we can envision are some interesting ways that you could use local storage, either through the HTML5 spec or possibly through, with that Python engine, you could do some local writing to the device, handle that field data collection piece, and then sync that back up via the Google Maps Engine API, which was just announced and released last week and then kind of reiterated yesterday, a full vector API for Google Maps Engine that allows you to write points, lines, and polygons. So the pieces are there. I think that's really where the developers come in. And we like to think of ourselves as a platform company. We like to provide the platforms and the capabilities, and then we rely on you all and your expertise to make this relevant in your individual vertical markets.
Just a quick extension. So there's no thought about sort of editing on the, well, I guess it wouldn't be on the fly, but stopping merge issues and that kind of stuff?
Yeah, so the Google Maps Engine API handles some of that version control, and then some of that's on their roadmap for how they're going to handle and deconflict. Again, what's really exciting at Google is we tackle these massive scale problems. The underlying infrastructure for the Google Maps Engine API is a really impressive piece of technology called Spanner, and there's a great white paper out on the open internet about Spanner. Check it out, and it really handles all of these conflicting edits in a very elegant way and does really interesting things at a kind of a global database scale. So definitely check that out, and the integration of the Google Maps Engine API with the offline capabilities of Portable is exactly the type of thing we're intent on helping develop and helping move forward in this ecosystem.
Thanks very much.
Thank you.
A question about the new JavaScript API that's probably coming out for Google Maps. With the preview functionality that we saw, that kind of brings the three-dimensional aspects to a lot of the JavaScript, the Maps API. For Portable, will it also get that same functionality at the same time as the preview gets rolled out to become mainstream?
So interesting question. Interesting way to phrase the question. So as you can imagine, we're kind of an API-driven company, right? So we don't have any announcements to make, but we're very focused on how we can allow you all and empower you all to build on these platforms. What you saw the other day with the new Google Maps is really kind of a cutting-edge immersive experience that still needs to mature and still needs to grow a little bit. As that does, as there's more functionality and capability added there, we're very focused on taking the best and brightest of that technology and making it available offline. But today, Google Maps Engine Portable and what we're doing with offline is really focused on that consumer maps and Earth experience that users have been accustomed to for the last few years. Those are the platforms that today consumers are using to make fast, informed decisions about geography. So,
okay. Thank you.
Thank you.
Okay, I would like to know with the Google Maps Portable, so we can grab the Google Maps online to an offline basis and also leverage some of the Maps API that do not need to have internet access. Am I correct?
Yeah, so it's a great point and a great point of clarification I'm glad you brought up. In the public version of Google Earth, for instance, you're seeing lots of different imagery that Google has acquired from a variety of different imagery providers. And we commingle and mix a lot of those pixels to provide a really cohesive visualization experience. We don't expect to release the ability to cut from Google's public imagery repository. What we are intently focused on is how you can cut your imagery out of Google Maps Engine, and then how also we can leverage the power of the data we use to build Google Maps tiles, the two-dimensional tiles, and allow you to take those offline for use behind the firewall, or on your local device. So that capability for the Google Map tiles offline is rapidly coming online, and we're really looking for the right trusted testers in the ecosystem who can help us prove that capability and that functionality. But to just be very clear, cutting Google's imagery is not something that's currently on our roadmap. Thank you. All right, with that, we're out of time. I would like to thank you all for your time, and Avnish and I will be around afterward if you'd like to engage in any further discussion. Thanks. Have a great day.